Yes. All right. So, our next speaker tonight is the regular speaker at Wrocław RB. He's a software engineer that is passionate about performance and making slow things work fast. Ladies and gentlemen, please welcome Chris Hasiński.
Hello. Does it work? Yeah, it seems like it. All right. So apparently I was banned at doing 3 or 4 talks in the row at Wrocław RB, but I am unbanned this year, so I'm doing one. And you might notice that there is a wrong date, because I actually made this presentation at several other conferences. But in the AI world, you can't really do the same presentation twice, because it's out of date. So here is an update. Yeah, I'll still have the same intro though, because I would like to talk to you about falsehoods, things that we believe that are right, but aren't. And there was this article about falsehoods about time, yeah, and it was very popular. There was a list of misconceptions that programmers carry around time. Things like the month always has 30 or 31 days, which is obviously not true. Some of them are like highlighted because people were actually arguing about those, like, does month always begins and ends in the same year? Turns out in Ethiopia, they start the year on September 11, so no, it does not always start on the same year. Yeah, there is even better repository with different kind of falsehoods, like not only the ones that are about time, but also, for example, about emails. Did you know that you can have multiple @sign in email? Apparently you can. But I would like to start another one, the falsehood that we believe about LLMs. And the first one is the most controversial, that they can chat. Turns out LLMs can't really do chat. They also can't think, and they can't really interact with anything. Because most of what they do is something like this. This is a Fibonacci sequence. It's basically you add a new item at the end that is based on some formula from the previous items. I call those things tokens in LLMs, and they look like this. They are actually really numbers underneath. But if you go to the tokenizer on OpenAI, this is a tool that they use to calculate how many tokens will you burn. You will see that different words give the different tokens. Sometimes it's a part of the word, sometimes entire word. In English, it's actually pretty simple because English is a popular language. It was overrepresented in the training set. So they get nice tokens, even tokens, like the tokens that you can actually read on their own. They make sense. They often start with a space because spaces are also popular in English language. If you have Polish, though, yeah, we burn a lot of tokens in that. Some languages are kind of cheating. Like this is Japanese. This says Nihongo Jozu des, Nihongo Jozu des, which means good Japanese. And this is the thing that you hear if you don't speak good Japanese. Yeah, they say Nihongo Jozu, and you're like, still bad, I need to learn more. And the word Nihon, which is Japan, is a separate token because it's a popular word in Japanese. Go is a language, so it's also a popular word, so it gets its own token. Jozu is actually one word, but these are 2 tokens, and des is like a grammar thing that will get its own token because it's super popular. So you don't really burn a lot of tokens, and you get like a very dense text. If we go back to this, we will have another number. But LLMs don't really work that way, that they have like a fixed formula based on some math. They are trained on data. They are trained on something, so this is also a good answer if this is in the training set. Yeah, and by the way, these are 2 tokens. We don't have to always get a new just one token. So, not all tokens are created equal. A lot of them include space, and the more exotic is the language and the character set, the shorter the token. And LLMs are basically a big token factory. What they do is they are really, really good at predicting next matching token. Wait, the next token that the trainer actually liked, because we have an extra step. The extra step is reinforcement learning. So They are not really representing the original source set, but they represent something that someone actually preferred them to output. Imagine the following prompt. Here is the prompt. Kind of empty. This was the original way of breaking ChatGPT, because if you don't give it any signal, or you give it something that like AAA, they will start generating random stuff. And the reason is that there is nothing they can base the next token on. Of course, if you type this into ChatGPT nowadays, you don't get the random answer. They programmed around it. They have something that processes the prompt, sees that it doesn't make sense, and give you a canned answer. There is a lot of prompt processing going on. So it kind of looks like this, and the LLM is just one of those tiny robots. And there is no chat. Chat is also something that is fictional. It's a processing trick. It's the only thing that actually exists are stop tokens. And what are stop tokens? Well, imagine the following prompt. You are like, this is a system prompt for some imaginary, very simple LLM. So you are an assistant. You will respond with, well, you will prefix your answers with something like assistant. The user will prefix it with user. And here's an example. End of example. Now the user has its query. And then we give the prompt to user. We don't run the LLM at this point. The user appends something, right? And then we take all of this text and we put it as a context for the LLM. And the LLM answers with 42. Then it answers with user because it wants to create more of the conversation. But that is actually stop token. This is the token that we defined that at this point, if you generate user, it means that you're not supposed to generate anymore. Stop. The user is doing stuff. So there is a program that is running LLM, and it specifically looks that the LLM is trying to write the response for the user, and it stops. If the LLM generates something that is not really matching the stop token, the LLM will actually carry on and answer itself, ask itself another question, which is really creepy if you're using voice model. This is from the OpenAI model page for the thing. It turns out if you miss a stop token on a voice model, the model will clone your voice and ask itself another question with your voice. This is real. If you use ChatGPT enough, you can see that sometimes it asks itself another question. They have like a sensor model now, so it immediately disappears, but you can still sometimes kind of find it. Sometimes there's like an opposite situation in which the stop token is triggered too fast and you get like a broken response. User are a terrible stop token, and I say plural because these are actually two tokens in this case. There are some like better ones. This one is really popular, end of text. A lot of the models have this pre-trained. They used to use NN in some older models, but this is terrible because it appears in a lot of text. And whatever you think that won't come naturally in the text might be a good stop token. If you run Llama CPP through, for example, Llama file, which is a really cool project, I highly recommend checking out Llama file. This is a binary that works on macOS, Windows, and Linux without any modification. Same file. Just download it and you have a model. They actually have some of this configuration available in the server that runs. They used to have stop tokens here as well, but I think they moved it into some configuration file. But you still have this template for a chat, and you can modify it. And sometimes the model misfires. You can get, I think this is the case, yeah. You can see some of the stop token. It missed one. It outputs something different. But Llama CPP has some protection against it, and it will still interrupt the flow. But this is an example of a tiny model that is misbehaving because it's missing a stop token. We can also disprove that the model can actually think. There is no thinking. If you run the reasoning model like O1 or O3, you will see this thinking magical box. Sometimes you will get a summary, which isn't actually what's happening. This is another model doing summary of what's actually happening. But at DeepSeek, you can actually see the reasoning, for example. And the model is just generating tokens. So it turns out, oh, sorry, yeah, this is the right thing. So basically, what is happening under here is that there is like a separate role in that chat that says reason, and this is just the tokens that we don't really show to the user. But it's still just generating tokens. There is nothing special about it. There isn't anything going on other than model outputting the text that you can't really see. There is also the thing about tooling. We're in this year that the agents are the most popular thing that you can have with AI. But none of this actually is real in the agent itself. Like, there is no tooling. Models can't really use tools on their own. You have to add something extra. So what they do is they abuse stop tokens, abuse embeddings, and abuse output formatting to make them agents. Abusing stop tokens is easy. You add another role, like with reasoning, that's called tool. And then you look for a specific invocation, and then you look for a specific stop token. So in this particular fictional prompt, you are an assistant that has an open weather magical API that you can use using this specific syntax, which starts with a tool, and then there is JSON with parameters, and then there is commit. And these are basically two stop tokens. There is commit and there is user. This isn't real. This is like a very simplified version of a system prompt. But what is happening here is the user types in something. The LLM outputs tool and invocation. We stop generating at this point. We call the tool. We take the output. We glue it back together into context. And then LLM carries on. So there is no action here. The program that runs the LLM actually calls something. The LLM doesn't really do anything. It just generates tokens as usual. So there is user prompt, tool function call, stop generating, tool response, and then LLM resumes. Of course, we don't really show it to the user. We hide it. We don't want to ruin the magical thing. We want to hide the processing, the extra tooling that we use to make the LLM do magic. So we do looking up weather, nice box, and that's it. This is a part of LangChain. They already switched to the JSON format. So there is some processing here as well. Like, this isn't responding directly to tokens, it's responding to a hash, but they are looking actively for something that looks like a function call, and then call this function. Yeah, so fast forward 6 months, because this is outdated, and now we have nicer things like Ruby LLM, which actually wraps into the readable code, not some magical thing that looks for double underscore, because the interfaces are now unified and everybody else is using OpenAI format that's really simple to use. You have just a list of tools to call. Of course, tools are old. Now we have MCP servers, because everything is outdated on every presentations on AI. But MCP servers is basically a meta tool. So you have a tool that allows you to list the tools, and then LM only gets the ones that is interested in. So you save a little bit of context, but they didn't do any kind of security checks on those, so any MCP server can break your model. Please be aware that if you're using MCP server, you basically allow someone to control your LLM. You can also abuse embeddings. We talk embeddings during the workshops, and embeddings are basically a version of a concept that is magically infused into a set of numbers. It's great for indexing unstructured data, and you can search for them, which means that you can basically find the data that is relevant to your model. So what you do is, if you have a phrase like 2 black cats with blue eyes, you can decompose it into a high level of catness, a little bit level of, I don't know, blackness, 2ness, and maybe high blue-eyedness. And this is basically an embedding that has those parameters high. So if you compare it to something that has like a low catness, it will not match. It's of course simplified because LLMs extract this data on their own and they don't really decide on concrete concepts like catness. They will find something more abstract. But if we go look at this example, there is like a nice Midjourney image, which is also outdated. We have much better image generators right now. So we have like a king which is high royalness, queen which is high royalness, and car which has low royalness. Then we have king who is very manly, queen who isn't very manly, and the car is also not very manly because it's an item. Yeah, there are distances between those items, but I think it's better to show them on a graph, which is not upscale XY, but still you can see that you can represent this on this very, very basic two-dimension embedding, and you can find the distances between those. Of course, real embeddings have like hundreds or thousands of dimensions, and they're all very abstract, but this allows you to search, and if you plug this into a RAG system, either using predefined lookup before the query or tool lookup during the LLM's response, you can actually put some relevant data for the user. Sometimes you'll need to pre-process the data, chunk it. Sometimes you need to convert the format for it to be able to see something like an image or video or audio. And sometimes you don't, because you have like a multi-model embedding models, which we used also during the workshop. Or the new one, which is the SIGLib from Google, also very nice. SearchGig supports, of course, embeddings, because, well, everything in the machine learning in Ruby is done by Andrew Kane. And of course, Neighbor, which is also done by Andrew Kane. If we lose Andrew Kane, we don't have a Ruby ecosystem anymore. Please don't lose this guy. This is really nice because it allows us to use something very simple like SQLite or Postgres to do basically a full vector search and stuff. There are also some of the tools, but the most important part, if you have unstructured data that you would like to include for your LLM, this is a good tool. And the only thing that I would add probably for 2025 is that also consider graph databases, especially generating graph databases with an LLM. This is also very cool. I think I have this over here. Yes, because there also need to be an update for those slides. A lot of people also use mixed approach, which is using classic search, like basically word lookup, using vector search, and perhaps use whatever else works, because right now there is no good solution for all the LLMs, and everything is in flux, everything changes all the time, and I need to update this presentation every 15 minutes for it to be up to date. Very frustrating. Yeah, so you can also abuse output formatting, because if you have all this data that you put into LLM, right, you still get a stream of tokens. Even if you use tools, even if you use everything else, you're still just getting text. Luckily, even though text doesn't really place nicely with functional programming or object-oriented programming, text also includes JSON. So what we used to do, because this is outdated, once again, is we use ask model nicely, please generate me data that matches this JSON schema. Then we validate the output against the schema, and if it doesn't work, we ask it again. This is exactly the same algorithm that we did with junior developers. Yeah, we ask them to do something, we validate it, and we yell at them until they do what we want. Yeah, fix it. This is a pseudocode. Please don't copy. I have to put this notice because someone did. This is basically how we ask models to do JSON response. And this is real. This is from taken, like the code itself isn't real because this is the real code. This is from LangChain. They have a prompt that basically says that, yeah, please format it according to those specs. Here are the specs in JSON schema. And if it doesn't work, they have another one, this one in YAML, because LangChain people, they can't really decide if they want to have templates or if they want to inline stuff. There are some ERB, there are some YAML, and there are some inline functions, but they all basically have prompts, and this prompt says, okay, that didn't work. Here is the context. Here is the error message. Please do it again. And that's how they do output formatting. Luckily, we have better tools now, and the language LLM servers that we have will do this internally, and you will get nice JSON response. You don't really need to do this. You will get also the messages listed in a JSON format, so you know you have like an array of messages with some metadata, with some full toggles. It's much better than it used to be. It used to be just text. So LangChain. I talked about several times about LangChain that we don't need it anymore. It used to be like an ORM for your LLM because we needed some common abstraction. We needed some extra things that we couldn't get from just a stream of tokens. But we moved all of this to LLM server, and now LangChain is basically dead. We have better stuff. Ruby LLM is really popular. It's growing very fast, but it might be growing a little bit too fast because the guy who is doing it has like a bazillion pull requests to go through, including mine. There are some nice tooling for the lookups, and like Neighbor from Ankana and Baran. I don't know who's the author of Baran. It sounds very Polish, right? Yeah. But it's something to chunk content into more meaningful parts, so we can embed them a little bit better. MCP servers are getting popular. We have several different implementations in Ruby, so you can have an MCP server that exposes data of your real application, which is really nice. And of course, we have the APIs from different vendors. They standardized a little bit OpenAI format, but there are some minor, tiny differences, so you might want to look into the docs if you're using any of them. And if you're using something like a meta provider, like Bedrock or OpenRouter, they're also slightly different, and they expose some subset of functionality for each model. It is still Wild West out there. I gave this presentation, and it was saying it was Wild West before. It is still Wild West. We don't have any good standards. Everything is in flux. Everything that you write today will be outdated tomorrow. But one thing that is to remember is that basically we have a new tool, the magical token generator, and we have a lot of software to write around it, a lot of it. So if you're worried about your job, you'll be doing a lot of this software. I would like to take some questions. Oh, sorry, I missed the stop token. Are there any?
Hi, thanks for your presentation, it's great. I have one question, which is when an LLM is generating, whether it's JSON or any other language actually, my understanding is that it is generating one token at a time, yes, and it's looking at the entire context every single time.
Yes.
So could you make it work with a fault-tolerant parser so that the moment that it was one token out of step with the fault-tolerant parser, it could tell you and like retry just that one token. So in the same way that if I'm writing in TypeScript, it can like tell me the next 3 valid words that you could type are these 3 words. It could also put that in the context live, like token by token. Is that something that people are doing, or is it something?
I think that Llama CPP already has something similar. I don't know if it's exactly this algorithm, but it's how they do the structured output. I'm quite sure that some of the proprietary providers do it this way. And also you can do this if you run low-level API on a model, like you're basically having a neural net. So you have a input, which is array of numbers, and the output, which is one number. Then you can basically, if you run it in a loop, how you generate tokens, you could do this quite easily. If you want,
it would have to be local, right? Because the latency would be, like if I wanted to hook it up to Ruby LSP so that it knew what Ruby LSP was predicting, it would be so slow to go back and forth to like a remote one. But I guess with like a dev server that had the LLM local and my code, it would be able to do that.
That's one of the reasons why they moved this feature from being client-side to being server-side, because they could check it quickly and interrupt the LLM if something is going wrong. They have new parameters for those, by the way. They have a minimum number of tokens, so they can ensure that you generate something. They have like a token callback, which you can remove one token and go back one token, so you start generating again with a different parameters. There is a lot of stuff to play in Llama CPP, so I highly recommend, if you're interested in it, I highly recommend downloading it and just playing out the parameters. It's mind-blowing sometimes.
Thank you.
Any other question? All right, so thank you very much, guys. And And I promise not to patch this presentation again. I'll make a new one.